Welcome to IST Decrypt's Deep Learning playlist. Today we are going to discuss forward propagation. What is forward propagation? In simple words, forward means moving ahead and propagation means the spread of anything. So in deep learning, forward propagation means we're moving in only one direction. That is, the neuron is computing an output by taking the input from the previous layer. What exactly happens in this phenomena of forward propagation? So, there are two main processes that take place. One is the pre-activation and the other is the activation. In pre-activation, we are basically calculating the formula y equals to wx plus b, which is called the weighted sum of inputs. In our activation process, we are passing this calculated weighted sum of inputs to a activation function. Now, why is this process important? As we know that y equals to wx plus b is a linear equation and it cannot be used to calculate a complex pattern. As we know, we are trying to replicate the way how a human brain functions through deep learning algorithms. So for that, we need some complex analysis and a complex pattern to be detected. And this is what the activation function does. It introduces a non-linearity to the network. And there are four commonly used activation functions. They are sigmoid, hyperbolic tangent, ReLU, and the softmax. Let us take an example to understand this in a more better way. So as you can see here, there are some 200 samples and these are used to generate the data, and it has two classes. One is the red color and one is the green color. This is just some random graph and it doesn't depict anything. We're just taking it to have a clearer understanding of what we meant by the two processes in forward propagation. So to the computer, it actually looks like this. You can see the neurons and their weights and their biases. Each neuron has its own weights, and depending on the number of inputs, it has that many number of weights. For example, at the first node of the hidden layer, A1 is the pre-activation and H1 is the activation. So A1 here is the pre-activation process and H1 is the activation process. And we finally give the output after the activation process. So A1 is calculated through this W1 into X1 plus W2 into X2 plus B1. And by taking these values, we have calculated the answer A1. Then A2 in the same way is calculated W3 into X1 plus W4 into X2 plus B2, and we've got an approximate answer. Now to calculate H2 or H1, we use the sigmoid activation function. And the sigmoid activation function has this formula: 1 by 1 plus e raised to minus x. And x over here is definitely A2. So our activation function's input is the pre-activation function's output. So the pre-activation function's output is A2 as we calculated, or A1 or A3 and so on. So for each pre-activation function, we will have an activation function. Here it's not been shown, but I will show you with A2. So with A2, we have calculated H2 and we've got an approximation and the answer is 0.44. In the same way for A3 also, we've done the same thing. Now what this means is, so for A3, we got 0.74 approximation. This means that there are 74% chances the first observation will belong to class 1. Like this, for all other observations, predicted output can be calculated. This example was just to give a clearer idea of how we exactly go about the forward propagation phenomenon. And there's no need to go into the depth of the example, just have an idea of how the activation and the pre-activation functions work and their importance. Thank you so much for watching.